Okay, class, we are going to start chapter 9. This is one of the most important chapters apart from the lines and slopes, because you're going to do this adding and subtracting and factoring polynomials as we move on. So remember, this is the foundation. It is a long chapter. There's a lot to it. So this is 9.1, adding and subtracting polynomials. So we're going to start here. A monomial is a number, or it can be a variable, or the product of a number and one or more variables with whole number exponents. The degree of a monomial is the sum of the exponents of the variables in the monomial. The degree of a non-zero constant term is 0. A constant 0 does not have a degree. I'm sure you understood all that, but let's go ahead and make it in a way that you understand it. So a monomial, they're giving you different examples, okay? It could be as simple as a number, 5, -6, 10. So here's 10. The degree is 0, okay? Because if I wrote this out, I would be saying 10x to the 0 power. What's anything to the 0 power? 1. So we know the degree of a number is just 0. Now here is another monomial, 3x, okay? And the exponent is 1, right? X to the first power. So the degree is the exponent. Here's another one, 1/2 ab squared. So it can be as long or as short as you want. So here's where you have two different variables, an a and a b. So a is to the power of 1. So if I wrote this out like here, a would be to the power of 1 and b would be to the power of 2. To find the degree, you have to add them together. 1 plus 2 will give you 3. Then here I've got -1.8 m to the 5th. So there's just one variable here, and the degree is 5. Okay? So on this side, it shows you what's not a monomial, one term. So 5 plus x, because it has a plus, if it has a plus or minus in between, it's not one term. If I have 2 divided by n, n is a +1. If I solved it, it would become 2n to the -1. Remember, by flipping, you're going to change it, and it's now going to become a negative. And you cannot have a negative exponent, and you cannot have a variable in the denominator. So either one works here. A monomial cannot have a variable exponent. So you can't have anything like 4 to the a, 5 to the b, anything like that doesn't work. And because of this and this kind of link together, you can see the variable must have a whole number exponent. So you can't have a negative exponent. And that's why this doesn't work, because if I actually solved it, it would become 2n to the -1. So understand, for these various reasons, these are not monomials. So no negative exponents, no variable in the denominator which would cause it to have a negative exponent, and no additional subtraction. So you can clearly see the difference. So remember, the foundation is always the most important, because this sets you up for this big chapter. So you have to understand these things, because we're going to build a lot on this. Okay, so now we're going to get to a poly. Now you know a poly is many or more than one. It can be as simple as one or more than one. So a polynomial is a monomial or a sum of monomials, each called a term of the polynomial. So when I say a term like here, this is a term, 5 plus x, okay? The degree of a polynomial is the greatest degree of its terms. So here is a polynomial, and it's made up of 1, 2, 3, 4 terms, okay? So that's how you decide how many terms, and I'm going to write that down here. So it does have 4 terms, all right? So, and they put it in descending order because that's how they do it, with the highest exponent first. 2x to the 3rd plus x to the 2nd power, x squared, minus 5 times x plus 12. So remember, if we wrote this out, this has an exponent of 0, okay? So they always put it in descending order, 3, 2, 1, 0. and they call this just the constant term, okay? So the leading coefficient is the number that is in front of the degree that is the highest degree. So we have x to the third, so that means the leading coefficient is going to be 2. And the degree is the one with the highest degree. Okay, so they go together, and we're going to practice that. So let's go ahead and do some. So let me move this. All right, so let's start here. We're going to write down this polynomial. So it says rewrite a polynomial and identify the degree and leading coefficient of the polynomial. So you always want to put it in descending order. So this is x to the third power, so this is going to go first. And the negative is assigned to this monomial right here, negative x to the third plus 15x. So you always want to write it in descending order. So when you do that, it's easy to answer the rest of the things that they're asking you for. So it wants to know the degree. The degree is 3 of this. The degree here is 1. So I'm going to do short is 1. And here the degree would be 0. Okay? So this gives you good practice. Also, identify the leading coefficient. So the one with the highest degree is 3. So the leading coefficient is the number in front, and that's going to be, and I'm going to put LC for leading coefficient because I don't want to write out leading coefficient all the time. So LC means, and I'll do it here so you do see it one time, coefficient. Hopefully I've written that right. Let me check. Yep. Okay, good. Sometimes my English skills have dropped off. I used to be a great speller. Now I'm so used to doing math, I have to think about it. So the leading coefficient is -1, okay? And then the leading degree, so I'm going to say LD for leading degree is 3. So it's just the one with the highest exponent, okay? So look at that. It's pretty easy to understand, but you just have to remember this. All right, I'm going to put this up because I've already done this. Sometimes it's nice and easy to use the graphs and charts that they have in the book. So a binomial and trinomial. A polynomial of 2 terms is called a binomial. So you know bi means 2, tri means 3. So they're using English vocab that you're already familiar with. They're not changing anything. It fits what you understand the vocab to mean. So we know that bi means 2, a bicycle, 2 wheels. A tricycle has 3 wheels. So here, tell whether the expression is a polynomial. So you've already learned what takes it from being a polynomial to not a polynomial. If it is a polynomial, find its degree and classify it by the number of its terms. Otherwise, tell why it is not a polynomial. So let's look at the first one. So we've got 9. Yes, we know it is a polynomial, and it has 1 term, and the degree is 0. Remember, we said that any number is x to the 0. This is 2x squared plus x minus 5. Yes, it is a polynomial, and it has 3 terms. I'm going to write that here. So we would call this a trinomial, okay? And the highest degree is 2. So second degree trinomial is what they said, okay? So this, 6n to the 4th minus 8 to the n. So this was fine, but then this is a variable here. So no, it is not a polynomial because of the variable exponent, okay? N to the -2 minus 3. So right there is the problem. It has a negative exponent, so no, it is not a polynomial. Then the last one, 7bc to the 3rd power plus 4b to the 4th power times c. Everything looks good here. Yes, it is. And remember, So count, you've got 3 plus 1 is 4, 4 plus 1 is 5. So it has a degree of 5, or to the 5th degree, and it has 2 terms right here. So we call anything with 2 terms a binomial. And actually, if we were going to write it in descending order, we'd say 4b to the 4th c plus 7bc cubed. Okay? So you can see that those are going to be important when to understand how to classify, understand what's a leading coefficient, a leading degree, and how to get all that. So now we're going to start adding polynomials. All right? So let me go ahead and start with a very, I guess I won't say basic one, but this would be a trinomial plus squared plus x to the 3rd minus 1. Okay, so we're adding a trinomial plus another trinomial. So just like you know that you can combine like terms, so 2x plus a plus 5x, sorry, that's a plus. I can add 2x and 5x because they're the same. I'd get 7x plus a. Okay, I can't add the a to the x because they're not the same. The same concept is here. They haven't changed it. You can only add terms that are the same. So what I'm going to do, excuse the bell, is write this 2x cubed minus 5x squared plus x, since it's a plus, put that here, 2x squared plus x cubed minus 1. And then what you can do as you're starting out is you can highlight like terms. So this and this are the same. They're both x cubes. I may use green to highlight anything else that's the same. I've got squared and squared. So those are the same. And then I have an x by itself and a minus 1 by itself. So now you add them together. So this does not change the cubes. You're not adding that together. You're adding the numbers in front. Just like you added 2x plus 5x, you only added the 2 and 5. You're going to do the same thing here. So 2 plus 1, adding the coefficients in front, gives me 3x cubed. And then when I've added them together, I cancel them out. So when you're first starting out, that helps to do that. After a while, as you get more proficient, you probably won't need to do that. But in the beginning, you're just learning. So minus 5 plus 2 is going to be a negative 3x squared. So now I've done that. So you're doing it in descending order. You're doing the cubes first, the squareds, and the next thing is by itself, plus x minus 1. And that's your final answer. Okay? And just to test you, this has 4 terms. The leading degree is going to be 3. I didn't ask for this. The leading coefficient is the number in front of the leading degree, which is 3. But it's good practice. Okay? So let's try another addition. Move this up here a little bit. So let's try this one. 3x squared plus x minus 6, so it's a trinomial, plus x squared plus 4x plus 10. Okay, so again, it's got a plus in between. I'm going to rewrite it like this. Plus x squared plus 4x plus 10. Okay? So again, I'm going to highlight anything that's got the same exponents. So I've got a 3x squared here and an x squared here. Then I've got x's that are the same. So that and that. And the last thing, let me look for a different color. Let me do a yellow. So I can add constants together, negative 6 plus 10. All right? So I know the x squareds are the highest degree, so 3 plus 1, that's understood to be a 1, gives me 4x squared. I've used them, I'm going to cancel them out. Plus 1x, so 1x plus 4x is plus 5x. I'm going to cancel that out. And then negative 6 plus 10, or another way you can say it's 10 minus 6, means the same thing as plus 4. Okay? And this is your final answer. Okay? So this is a trinomial. Has 3 terms. Leading coefficient is 4. Leading degree is squared. Okay? So I'm reinforcing it so you see it again and again. The next one we're going to do is subtraction. So there's just one thing you have to be careful when you're subtracting. So let me turn this over. There we go. Let me move this. All right. Okay, so here we go. 4n squared plus 5 minus, parentheses, negative 2n squared plus 2n minus 4. Alright, so this is where you have to be careful. You're subtracting. When you subtract, it's like having a negative 1, and all the signs after this change. They don't become positive and negative, they change. So the first one does not. So I'm going to go ahead and write 4n squared plus 5. Now because I have this minus, I'll think about it like a negative 1, and you are distributing it, you now get a plus. This minus becomes a plus 2n squared. This positive is going to change signs. So just remember that all the signs change if you have subtraction. Okay? So this plus 2n now becomes a minus 2, and that's the biggest thing that you have to remember. The minus 4 is really a plus 4, because remember, if I multiply by negative 1 changes everything. So that's the one thing you have to do when you have subtraction. You've got to change the signs, and then do the same thing you did, add them together. So here I've got a 4n squared plus a 2n squared. So those are like terms. The only other like terms are the constants, 5 plus 4, and we have a negative 2n by itself. But we're going to write it in descending order. So 4n squared plus 2n squared is 6n squared. Minus 2n is by itself. That's the next one that comes in descending order. And 5 plus 4 is plus 9. So again, I have a trinomial. Has 3 terms. The leading degree is 2. The leading coefficient is a positive 6. Okay, we're going to try one more where we're subtracting 2 trinomials. So here we go. 4x squared minus 3x plus 5, subtract minus 3x squared minus x minus 8. Okay, so I'm going to write the first one. It stays the same. 4x squared minus 3x plus 5, and this is where I have to be careful. So I have a subtraction, so that means this will become a minus, this will become a plus, and this will become a plus. So I do that first. I rewrite it so it's correct. I just change all the signs. Okay, so when I've done that, I'm going to do what I did before. 4x squared and minus 3x squared, they're the like terms. Negative 3x and plus 1x are like terms. And the last one, my yellow highlighter, is 5 plus 8 are like terms, they're constants. So then let's write it in descending order. 4x squared minus 3x squared is 1x squared. We don't have to write the 1. Done with that. Negative 3x plus x is negative 2x. Done with that. 5 plus 8 is 13. And that is it. So you've learned to add and subtract, and I'm just going to throw out one word problem here, which is just, they set up a word problem and you're just going to add together the polynomials. So here we go. Major League Baseball teams are divided into 2 leagues. During the period 1995 to 2001, the attendance N and A in thousands at National and American League baseball games, respectively, can be modeled by N equals negative 488 T
One to the
squared.
front office, one to the front office.
Sorry about that. Plus 5,430 T plus 24,700. And A, okay, remember these are in thousands, is negative 318 T squared plus 3,040 T plus 25,600, where T is the number of years since 1995. So they have to tell you about how many people attended Major League Baseball games in 2001. So what you're going to do is add the models for the attendance in each league to find a model for M, the total attendance in thousands. Yep, so you're going to do that. So when you add them together, you can see they put the first one N plus A, and you can see here that they added the like terms. They split them up. They're showing you negative 488 T squared. The plus isn't going to change anything, so minus 318 T squared. Then they added the T's together, 5,430 plus 3,040 T, and then they add the constants together, 24,700 plus 25,600. When you add all like terms together, you ended up with negative 806 T squared plus 8,470 T plus 50,300. So that is your new polynomial when you added these together. Then the second thing is you're going to substitute 6 for T in the model, because 2001 is 6 years after 1995. So remember they said the T was when it started in 1995, and since they want to know in 2001, that's 6 years later. So everywhere that you see a T, you can plug in 6, and when you do that, you get 72,100. So about 72,100 people attended Major League Baseball games in 2001. So you're seeing the growth there from 1995 to 2001. Okay, so you can see how they added the models together, N and A. They came up with a new polynomial, and then you plugged in 6 for time because it's 6 years since 1995, and that gave you the attendance. Okay guys, very important concept that you understand this, all right?